All right, this is 3-4. This is talking about arithmetic sequence. So totally different what we've been covering in chapter 3, talking about functions, but this is an arithmetic sequence. I'm sure you've seen this before. It's just, the definition is a list of numbers that has an addition pattern from one number to the next. And so let's just look at it and then analyze the differences. So let's look at this first pattern. This first list of numbers, so we go from 3 to 9 to 15 to 21 to 27, and then dot, 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 because it keeps going on forever. Well, what do you notice the pattern? From one number to the next, it looks like from 3 to 9, it looks like it's adding 6. And again, it isn't, we're looking for addition patterns. So let's see if this pattern is true. So does it add 6 again? So 9 and then plus 6, is it 15? Well, it looks like it is. And then we're adding 6. So yeah, the pattern stays the same. So the rule is I'm adding 6 to that list. So there is an addition pattern on that. So when I go from this next one, 8 to 6, it looks like I'm subtracting 2. And again, I know this is arithmetic sequence, but remember, subtracting 2 is the same thing as adding a negative. I mean, if you want to put a negative 2, but remember, that is still the same thing as adding a negative. So let's see if that's true. Yes, minus 2, minus 2, minus 2, minus 2. And so the rule is I'm minusing 2 from each number to the next. And again, let's look at the next list, 12 to 19 to 26. Well, it looks like I'm adding 7. Make sure the pattern holds. Make sure that the sequence really is arithmetic sequence. It literally adds. There are different types of sequences, and the one that we're talking about here is arithmetic. So make sure it adds from one number to the next all the way through. So here it adds 7, here it adds 7. So yes, the pattern is adding 7. And the last example, notice it goes from 1/2 to 1, and then 1 to 1/2, 1 and 1/2, and then 1 1/2 to 2. Well, it looks like it's adding 1/2, and you can see it stays consistent throughout each one of them. And again, that's what an arithmetic sequence is. So what if we had an example of finding the next 3 numbers in the sequence? Well, again, you got to notice the pattern, and then from that, continue the pattern. So if I had 14 and then the next number is 9, well, what does it look like the pattern is? Well, it looks like I'm subtracting 5. And then let's see if the pattern holds true. So does 9 go to 4? Well, that looks like I'm subtracting 5. And then from 4 to -1, well, that looks like I'm subtracting 5. And then so forth and so forth. So to find my next number, I'm going to subtract 5 more, and that's going to give me -11. And then subtract 5 more, that's going to give me -16. And then subtract 5 more, and that's going to give me -21. So my next 3 numbers would be -11, -16, and -21. Let's go to the next one. So here's a list of numbers. So from 38 to 49, what does it look like the adding pattern is? Well, it looks like we're adding 11. Well, let's see if that holds true. So if I add 11 more, does that give me 60? Yes, it does. Add 11 more, it does give me 71. Add 11 more, it does give me 82. So it looks like I'm adding 11. So let's continue the pattern then. So I'm adding 11. So my next number would be 93. And then I'm going to add 11 more. That would be 104. And then I'm going to be adding 11 more, and that's 115. So I found my next 3 numbers in the sequence. Now, there is a formula to actually do this for us instead of continuing on. So this is the formula that we need to make sure we understand what we're talking about. And before we even talk about that, make sure we understand a little bit about the sequence. So when we talk about a sequence, this is the first number in the sequence. So we would actually label this A1, A sub 1. So that's the first number in the sequence. This is the second number, so this would be A sub 2. This would be the third number, so A sub 3. And then fourth number, fifth number, sixth number. So even like this would be A sub 6. So it's the sixth number in the sequence. And then so forth and so forth. So all the way until we get to the 7th, the 8th, the 9th number in through the sequence. So when I get to this, This is a sub n. So, whatever I want to find, I'm going to be looking at the next term, the 53rd term in the sequence, the 117th number in the sequence. So this n is referring to the nth term. So whatever term I'm talking about, I might be talking about the 5th term. Then this would be a sub 5. If I'm talking about the 10th term, this would be a sub 10. So that's what I mean by the nth term. Now a sub 1 right here is talking about the first term in the sequence. The n minus 1, the n is again referring to the term position. So whatever number I'm talking about, again, that's the n right there. So the 4th term or the 5th term or the 53rd term, that's what the n stands for. And then again, the d is the common difference in the sequence. So let's actually go about the pattern and let's find a couple things in it. So let's look at this example. So here we have 4, and notice that's my first term. So that's your A1 right there. This is your A2, your second term of the sequence, your A3, A sub 3, A sub 4, A sub 5. And then if I wanted to find the next term in the sequence, that's what this is, that means I'm trying to find A sub 6. I'm trying to find the next term. I'm trying to find the 6th term in the sequence. Now, first of all, let's find out the pattern. So notice the pattern is going, it looks like I'm adding 6. So 4 plus 6 is 10. I'm adding 6 more is 16. I'm adding 6 more. So the pattern is adding 6. Now, I know I could just add 6 to get to the next term. Okay? I could do that, just add 6. But I want to show you that the formula does work. So if I wanted to find the next term, I want to find, which is the 6th term. So I'm trying to find a sub 6. What I would do is follow this formula. It says a sub 1. Well, the a sub 1 is the very first term, which is 4. And then again, follow the formula. So plus, and then in parentheses, I'm trying to find, this says n minus 1. Well, n again is whatever term I'm trying to find. So the next term is actually the 6th term. So this would be 6 minus 1. And then it says times the d, the difference. Well, the difference is, remember, I'm adding 6. That's the difference, the common difference between each term. And so if I just work this out, so 4 plus, and then 6 minus 1 is 5. And then 5 times 6. So this would be, again, following PEMDAS, so you do multiplication, that's 30. And this would be 34. So the next number is 34. And of course, we could have just found that just by adding 6 in the first place. But I wanted to show you that the formula does work. And so this formula does come in handy. So if I wanted to find, let's say I wanted to find the 53rd term. And you're like, what? And the cool thing about this formula is it works for whatever term I want. I don't want to actually keep adding 6, adding 6, adding 6, adding 6 until I get to the 53rd number. I don't want to do that. So I want to use that formula. So here I'm going to find a sub 53. And again, follow the formula. It says a sub 1, the first number in the sequence is 4. And then it says n minus 1. So n again is whatever number I'm trying to find, 53. And you're minusing 1 from it. And then again, the common difference in this sequence is 6. So you're just going to solve this problem and then be able to find out what that 53rd term is. Well, 53 minus 1 is 52. And then 52 times 6 is 312. And then 312 plus 4 is 316. So the 53rd term in this sequence, if I kept moving on the 53rd term, the 53rd term would be 316. Let's look at one more example just to make sure we understand how to use this sequence. So again, we have a list of negative numbers. So here's the list of negative numbers. So again, this is your A1, this is your first number, A sub 1. This is your A2, this is your A sub 3, A sub 4, A sub 5 again. And you should be able to notice the pattern, what's taking place from one number to the next. So notice what's happening from this number to the next number. It looks like I'm subtracting 7. And let's see if the pattern holds. So if I subtract 7 more, yes, I get the negative 38, subtract 7, and then so the pattern does hold. So I'm subtracting 7 is the common difference. So if I wanted to find the next term in the sequence, again, I could just simply subtract 7 and I could see what my next number is. But let's follow the formula just to make sure I understand how to use that formula. So the next term in the sequence, I'm trying to find a sub 6. That's what I'm trying to find. So again, follow the formula. The first term is negative 24. And n minus 1. So the n again is the next term in the sequence, which is 6, and then minus 1. And the difference on this pattern is negative 7. And then I'm just going to calculate this to find out the next term in the sequence. So 6 minus 1 is 5. 5 times negative 7 is negative 35. And negative 24 plus negative 35 is negative 59. And again, I could have found that just by literally doing the next number. But I wanted to show you that the pattern, that the formula does work. So again, let's try it again on a bigger number. So what if I continue the sequence all the way to the 32nd term? I want to know what the 32nd term is. Well, that means I want to find a sub 32. Well, again, follow the formula. A sub 1, the very first number in the sequence is negative 24. And then n minus 1, I want to find the 32nd term minus 1. And again, the difference is negative 7. And then you're just going to do the math here. So negative 24 plus, and then 32 minus 31. 32 minus 1 is 31. And then 31, I'm going to work sideways because I'm running out of space here. So negative 24 plus, and I'm going to multiply 31 times negative 7, which is negative 217. And then negative 24 plus negative 217 is negative 241. So the 32nd term in this sequence right here, the 32nd term is negative 241. And that's how you do arithmetic sequences.